Mary runs off a ledge that is 1 meter above the river. As she does this, she grabs a vine and swings to the opposite side. The opposite side is 2 meters above the river. Does she make it up to the opposite side? Well, I've got a picture already drawn of this, and what's not mentioned in the text, but it is in the picture, is the 5 meters per second. Sorry, it's not in the text, but she's moving at 5 meters per second. And she's going to grab the vine, which is 1 meter above the river, and swing to the other side, which is 2 meters above the river. The question is, does she make it? So what I really need to know here is, what is the maximum height that she will reach? Well, at the maximum height, I know the velocity is going to be equal to 0, because that you will have spent all your kinetic energy and given as much to potential energy as you can. So that's going to be 0. So I'm going to compare the energy at the opposite side of the river, because the question says, does she make it up, how high on the opposite side? So I want to find her maximum height when she's on the opposite side. So I'm going to look at the kinetic energy and the potential energy. And I need another location where I know the speed and the height, and that's going to be on the left side. That's where I'll compare that kinetic energy and that potential energy. So what I'll do is I'll show that I'm going to conserve energy, use conservation of energy. I'll use a sigma, capital E, and I'm just going to write left and right in this case. Left equals sigma, that means sum, and capital E, that's energy, so I'm going to sum up all the energies on the right. And the only energies I'm looking at here are going to be the kinetic energy on the left plus the potential energy due to gravity on the left, and that's going to be equal to the sum of the kinetic energy on the right plus the potential energy due to gravity on the right. All right, so now I'm going to go through these questions and look at velocities and heights. So on the left, is she moving? Yes, it's 5 meters per second, so I'm going to keep kinetic energy in my equation. Is she above the other location's height? She's not. She's above the river, but not the other location's height. So since she's not above the other location's height, that's going to go away. On the right-hand side, is she above the left-hand side's height? Yes, she is. So I'm going to keep that energy. And on the left-hand or the right-hand side, is she moving? Well, the condition for maximum height, it's implied that you've spent all your kinetic energy and your velocity is 0. So no, she actually isn't moving when she reaches her maximum height. Think back when you played on the swings on the playground in elementary school. You swung up as high as you could. At your highest point, you lost all your kinetic energy and you stopped, and then you came back down to the lowest point again. So that's what we're talking about now, is that highest point. So this creates my equation. I have kinetic energy on the left and potential energy on the right. So on the left, I'm going to have 1/2 mv squared, and that's going to be equal to mgh. The m's are going to divide out. So 1/2 v squared is equal to gh. I'm solving for h, so I'll divide both sides by g. That's going to be v squared, and that'll be divided by g, so that's v squared over 2g is equal to h. Now I'll plug in my numbers. H is equal to the velocity squared, 5 meters per second, divided by 2 times 9.8 meters per second squared. Notice it's not negative 9.8 because g, energy is a scalar, so the negative sign was for direction, and I don't care about the direction, so I'm just going to put a positive value in for g. And then when I do the calculations, I get the height to be 1.28 meters. So assuming there's enough vine to go horizontally across the river, she has enough speed at 5 meters per second to make it up to the height of that ledge and then some. So she can make a maximum height of 1.28, and the ledge on the other side is just 1 meter higher. So yes, she should be able to make it.